Hello and welcome to our next discussion on observational versus experimental study designs. What I'd like to do in this video is to talk about how these different study designs fit in the general scope of research, and then touch on several of the study designs for our current chapter that we are studying. So let's go ahead and think about the different kinds of study designs that we have. And I like to frame this from the perspective of how much information do we already know about a specific topic. And for the times that we don't have very much information, we use certain kind of study designs down here. And then as we get more and more and more information about a certain topic, we tend to use study designs that are farther on this other end of the spectrum. So what are those study designs? Well, let's go ahead and add them to the chart kind of in order. And I generally start by talking about case reports or case series. It's an S. And a case report literally is just a report of a case of a particular disease. And so I'm going to go ahead and draw that and give you a little bit of a visual. I'm going to draw a little stick man, and he's going to have maybe the chicken pox. He's a little red stick man. So here he is. He's maybe not too happy. Oh, he looks very angry. Okay, he's just meant to be sad. So he's a sad stick man because he has chicken pox or some other disease or rash. And in a case report, we simply take note that, wow, there's this case of something I wasn't really expecting, or a case series, there might be a whole bunch. So if you think about back in the 1980s when we first started noticing all of these cases of people who were having problems with their immune system. They were young people. They were having diseases that people shouldn't have, cancers, until they were much, much older. We eventually figured out that this was HIV/AIDS, and it started off by physicians doing case reports. They said, hey, I'm noticing all of these cases of things I wouldn't really expect, and publishing those in their own subject discipline. And other people taking notice saying, hey, you know, I have that same thing I've noticed. So that's often the thing that will get our research going. And if you notice, it's way down here at the bottom at the point where we do not have very much information about a specific topic, and we're really just noticing something. So that's case reports and case series. The next one on the list that I'd like to share is called a cross-sectional study. And with a cross-sectional study, we take a group of people and we ask them, what's your, I'm going to do it in another color, what's your exposure? Have you been exposed to a particular environmental toxin, or do you take this drug, or different things like that? And do you currently have a particular disease? Maybe we're wondering about heart disease, angina, diabetes, other kinds of things. So we just ask them at a certain point in time, do you have these things? And for this particular situation, I'm going to draw a chicken and an egg, because when there's his little feet, I'm doing this so that hopefully this will help you remember. There's his beak, there's his little eye, there's the chicken, there's his egg. Because with a cross-sectional study, one of the big things about a cross-sectional study, probably needs some wings, we'll give him some little wings, is we don't know which came first, the disease or the exposure, because we're just simply asking about them at this single point in time. And so that can be one of the things that can help you hopefully remember that. Very similar to a cross-sectional study, and I'm going to say down here, maybe this is, I'll have to do some erasing if I do it this way. let's go ahead and do that now. I'm going to put the case series also down here at the bottom, case series, because I want to talk about studies that are done on an individual level and then studies that are done on a group level. And by group level, I mean something similar to the DOT data set that we have recently been working on. We have information about 50 states. We don't have, and that's on the group level. We don't have information about the individuals in that state, in that particular data set. It did come from somewhere way back, but in that particular data we are observing and analyzing on the group level. So similar to a cross-sectional study, but done on a group level, is something called an ecologic study. And typically when people talk about ecologic studies, they are talking about what's called an ecologic comparison study or an ecologic cross-sectional study. And so that's why it's very similar to the cross-sectional study that we see down here that's on an individual level. Essentially, with this kind of a study, we are finding out all kinds of information at the same exact time. We're finding out about disease rates in a certain country. See how we're on the country level. We're finding out about exposures in certain countries. This may be we're finding about incidence or prevalence or mortality in those countries. And so ecologic studies are very flexible. And for this, I'm going to draw, just to remind you, that ecologic studies are on a group basis. So here I have maybe my little world on a stand. I'll draw some land in here. Okay, that's supposed to be a generic continent. Okay, so ecologic studies on a population level. So we may be comparing states to states or countries to countries or census blocks to census blocks, but we're not down on the actual level where the individuals are having exposure and disease. We're reporting those on a group level. So that's another kind of study that we see. The next kind of study, the rest of these are all on an individual level. There are other ecologic level studies that can be done, but typically this is the one that most people are thinking of when you talk about an ecologic study. So for now, we'll just stick with that one on the group level. The next type of study design on an individual level is a case control study. And in this case, not only do we have, like as in case reports, we have cases here. So here I'm going to draw my little stick man. He has some bad, sad thing going on. Poor guy. So he has the chickenpox or whatever. But then we also compare those cases to another group of controls who don't have the disease. So here we have a comparison, the possibility of comparing between those two groups, whereas in case reports or case series, we don't have the possibility of comparing across groups. With case control, then we can compare. And so with case control, the defining feature about them being a case or a control is the disease factor. And then we ask them, what was your exposure to whatever thing that we are wondering about? So that's the next kind of study. After that, we think about a cohort study, and there are a variety of different ways of doing a cohort study. With a cohort study, we take a whole group of people and we follow them forward in time, or if it's retrospective, we look back in time. But the main idea here with a cohort study is that we are thinking about time. And so we're either going forward or back, but time is the primary thing that sets this type of study apart from the ones that we've looked at previously. So cohort study, we have this group of people and we're looking at what happens to them over time. We measure, at the beginning of time, we measure exposure. And then we follow them forward and find out if they get the disease. So that's a little bit different than what we talked about with the case control study. And then finally, the last one that I want to mention here is the experimental. And I'm just gonna include, for now, I'll just say trials or clinical trial. There are a variety of things that fall in this general category that are similar to these. We may call them field trials, quasi-experimental, natural designs, natural experiments, community trials. So there are a variety of things, and we will talk about that in the future for our class, but for now let's just use this one as our kind of example. And the thing that I'd like to point out is that if we're thinking about this whole idea of observational versus experimental, everything over here on the left-hand side is observational, and what we have over here on the right-hand side is experimental. And the thing that sets experimental study designs apart is that the exposure, and I'm just going to write this, exposure is assigned. And what I mean by that is whatever it is that's this exposure that we're talking about here, cohort has an exposure over time, that exposure in an experimental study design is decided by somebody other than the person who is the study participant. And so depending on what it is, if it's a community trial, if it's a field trial, a clinical trial, a quasi-experimental design, or a natural experiment, that exposure is dictated by somebody else. In a clinical trial, that exposure is assigned by the researcher to the person who is in that trial. And so by definition then, in observational studies, the exposure is selected by the individual. By the subject. In some way, they choose what foods they eat, they choose whether they're a smoker, they choose where they work and live and what kind of activities they do. Most people in just a free living society choose all kinds of things. And so a lot of our studies that we do fall into this observational design. A few things that you should note about this whole idea of the amount of information that we already know about a topic. Early on, we choose these kinds of study designs because they tend to be faster, easier, and less expensive. Now that's not across the board. There can be very complicated cross-sectional studies and there can be much easier cohort. But in general, if you're talking about the same kind of a topic within this spectrum, the ones on the left tend to be easier. Let's see where I can write this. Easy, cheap, and fast. And part of the reason for that particular piece is because we often, early on, when we don't know very much about a particular topic, we try to find existing data. And so we may have some existing data about, on a country level, how much of a certain kind of food do people eat. We may find out about what's the air quality in that particular area and relate that to the country statistics on morbidity and mortality. We can also do the same thing on an individual level where we sometimes can find existing data, which is called secondary data, of, just so happens that someone did a study and they collected information and they have this data that could show us that kind of relationship. Over here on the right-hand side, because we're asking much more specific questions, the amount of information we know forces us to ask more complicated questions. Let's go ahead and move this up. I'm going to just move this up farther into the field. We're asking more complex research questions. And so what that means is we need to collect our own data often, because it may, the specific question that we need to ask may not exist out in the real world. And so this is, again, it's a spectrum that is not any kind of hard and fast rule about the existing data and the collecting your own data kind of thing. But in general, the farther across this spectrum that you get, the more unique your research question ends up being, the more you have to collect your own data for that particular question. So, just as a general rule, I would like for you, when you get to the end of this, to be able to really understand the study designs rather than memorizing a lot of facts or details. So that's kind of why I'm giving you this kind of level of information. Also, okay, so over here on the left-hand side, we tend to think about hypothesis generation. And over here on the right-hand side, we're thinking more about hypothesis testing. So this is where we don't actually even know what question we're wondering about. We're generating hypotheses about what relationships exist. So that's kind of just a general gist of this scope of those different types of things. The thing that I want to point out about this exposure is assigned. Some studies may progress. They may have a case report and then an ecologic study, maybe skip over case control and then start looking at cohort studies, and they may never get to clinical trials. And part of the reason for that is it may be impractical or even unethical. To assign that particular exposure. So for example, it would not be ethical for us to assign people to be smokers. We know enough about that, so the amount of information that we know enough about that particular exposure that we can never go on to this clinical trial phase. There are lots of things, though, that we don't know for sure about. We may have a hunch, but then that's worth going to that particular level to do research on that particular topic. So let's go ahead and talk then about a couple of these study designs. So here we have a cross-sectional study design. And remember how with this particular study design we collect a bunch of information from people and we collect that exposure and disease at the same time. So I'm going to draw that. Let's say here we are, we're kind of going through time, we're like, hey, we'd like to know something. So we collect information from a group of people on exposure and disease at the same point in time. And we're not able in that particular situation to show which one came first, hence the chicken and the egg. So here we have our exposure and here we have our disease. Let's say we collect 1,000 individuals. So I'm going to go ahead and represent that by saying here's my 1,000, that's my total individuals, and I find out that there are a certain number of people in each of these different categories. Maybe there are 40 here and 60 here for a total of 100, and maybe I have here, then this would be 900, right? So then maybe I have 850 and 50 here. So that then I can add those up and I know my totals. 910. So here I have a total number that I started with, and what I did is I found out how many of them were in each of these 4 categories. Then, based on that, I can calculate my 4 what are called marginal totals. And if I started with a random sample from my population at some point, if I have the whole population and I just randomly selected 1,000 people, then I could do something with prevalence. Remember how I have cases here and I have non-cases? And here's the total. So cases plus non-cases equals total. Prevalence is equal to cases over cases plus non-cases equals cases over total. In this case is equal to 100 over 1,000, which is equal to 10%. So I can find out something about prevalence a lot of times from cross-sectional studies, and that's the reason that they are sometimes called prevalence studies, because what we're doing is we're just finding out the prevalence of disease, the prevalence of certain exposures, the prevalence of demographics, the prevalence of all kinds of information. We're just figuring out how many people have what. So cross-sectional studies don't automatically have to cross-tabulate between exposure and disease. Sometimes all we're interested in is these rough prevalences for each of the different variables. But cross-sectional does lend itself to be able to do this kind of thing. So that's about cross-sectional studies. I want to add a little something here. This would also be, if you think about the ecologic studies that we were talking about, the ecologic comparison studies, then they would be very similar to cross-sectional studies. The only difference is that we're collecting a certain number of whatever other unit of measure. This is on the group level, remember? So we have a certain number of groups that we're studying, and then for each of those groups, we want to know about exposure levels, we want to know about disease levels, and so these ecologic comparison studies are often done more on the continuous variable level. So remember, here we have exposure and disease. We talked about this before. So you'll see some examples of that in your textbook, where maybe we have, for each of the countries, they fall at a certain location. So the ecologic comparison studies do a very similar thing, where they measure all of this information at a given time and show relationships, and they often are very hypothesis generating then. Finally, we have our case control studies, and in this particular situation, we collect a bunch of information about cases. So here's our very sad people, and they have, whatever it is, be it the chicken pox or whatever, and then we have a whole bunch of people that are then controls. And often we collect a 1-to-1 or 2-to-1 or some kind of ratio between the cases and controls. And often then we know exactly how many cases and controls we have. So in your particular textbook, we have an example of the relationship between chili pepper and gastric cancer. And so what we find in that particular example is that we had 213 with gastric cancer. I'll put that here. And then what we did is we collected 697 controls that we also wanted to look at. Now, if this particular disease has nothing to do with, and here I have my chili pepper, exposure, yes, no. If this disease, gastric cancer, has nothing to do with chili pepper, then I would expect the same proportion of yeses to nos for these two groups. Of the 697, I would expect a certain a number that had been exposed to chili pepper, and of the 213, I would also expect a certain number. So we ask them, we ask all 213 people, how many of you on a regular basis have red hot chili peppers as part of your diet? And we got the numbers 204, and 9 of them said, no, we don't. And so then we went over to the people who didn't have gastric cancer, 697 of them, and we said, do you on a regular basis have hot chili peppers with your food? And 552 of them said, yeah, I do. And the other 145 said, no, not really, I'm not that into hot food, hot spicy food. Now, right away, if we just look at the relationship between these numbers, 552 and 145 versus 204 and 9, we can see that this looks like it's much more heavily weighted in this particular corner. In fact, when we do the odds ratio, and I'll show you quickly here how to calculate that. Odds ratio is equal to the odds amongst the cases. So 204 divided by 9, and then divide that whole thing by the odds among the non-cases. So 552 over 145. Now there are ways of simplifying that so you're not dividing and dividing. But right now, for conceptual, I think it's important to look at that as the relationship between the yeses and nos for the cases and the relationship between the yeses and nos for the non-cases. That odds ratio ends up being 5.95. And so what that means is that the cases are much more likely to be in the yes category than the non-cases are. And if we think about it, the non-cases could be kind of like considered to be our baseline. If we have 697 people, we would expect 552 of them, or a certain, whatever that percentage, to eat chili peppers, to be exposed to chili peppers. However, when we got this 213, it looked like a much higher percentage. It ends up in the chili pepper category. So that tells us something about the relationship between chili peppers and gastric cancer. Now, the hard part about this whole thing with case control studies is that we manipulated the data here. We manipulated the 213 versus 697. We decided that we were going to collect the 213 and the 697. That does not add up, and I'm just going to put an X over here, that does not add up to some population number so that we can calculate the prevalence. Imagine this, imagine you collect 30 cases and 30 controls. Would you then say that 50% of the people, if that's added up to 60, would you say 50% of the people in the population have that particular disease? No, because you decided you were going to collect 30 cases and 30 controls. And so that does not represent this population level. So that can be a real downside to case control, is that we don't have what a lot of people would call denominator data. We do not have the denominator, so we can't calculate prevalence and risk and those kinds of things. We're stuck with this odds ratio. So odds ratio is the measure that we use for case control because of that limitation. So let me go ahead and show you one more thing. And this kind of goes back to the whole idea of thinking about the types of studies that we're using. And so this is a table that I like to use in terms of talking about the study design. So here's our case report, here's the ecologic study, here's a cross-sectional study. My pen is acting up. Okay, so you'll just have to imagine I'm pointing. And then we have case control. So do I get to draw? Maybe. So I like to think about what is the defining feature about that particular study design. And your book does not talk about case reports very much, so I've included that information on the table already for you. But the thing about a case report is that you have this one case, or if it's a case series, you have several cases that are unusual, but you have no comparison group. And so you really can't say anything about prevalence or incidence, or it's very limiting. So here, I guess I skipped over this. For the giraffe, the defining feature is his neck. So that's the thing that a lot of people think of when you see a giraffe. That makes it so that it's easy for him to eat things that are way high up off the ground. So that's an advantage. However, when it comes time for the giraffe to drink water, which tends to be on ground level, that ends up being a limitation for him. So whatever that defining feature is, tends to also be the thing that is the advantage for that particular study and the limitation for that particular study. So what I'd like for you to do is think about what makes certain things, certain study designs good or bad. And all of the defining features have advantages and limitations. So if we were to go back to the other page, we talked about ecologic studies. The defining feature there is that the unit of observation or analysis is on the group level. That makes it super easy to find existing data. It doesn't take as much time, money, that kind of thing. So that can make an ecologic study really easy to do. However, because we collected information on the group level, those results may not then apply to individuals. And so it might be that we see a relationship on the group level that does not exist on the individual level. So we need to be careful about our interpretations. For cross-sectional, the defining feature there is that the exposure and the outcome are measured at the same time. We have a single period of observation, as the book would say. And so if I collect all of the information all at once, then I can't lose anybody from my study. I have no loss to follow-up, which is a problem in some of the more advanced studies. Also, again, cross-sectional studies tend to be less expensive. You can use some existing data. They may not take as much time or money because you're just collecting them, let's say, all in the same month or all in the same year, whereas some of the experimental studies will go on for years or decades sometimes. However, since we collected things cross-sectionally, remember our chicken and our egg, we cannot establish causation. We often cannot measure the temporal ordering of cause and effect. Here we have exposure and outcome right at the same time. And so we don't have the luxury of establishing that level of causality. For case control studies, the defining feature is we find a bunch of cases, then we compare them to a bunch of non-cases. Great. That means that if I have a rare disease, and your book talks about this a little bit, then I can find all the cases of that particular rare disease. That's a huge advantage. Whereas if I just got a whole population, let's say I got the whole population of San Bernardino County and I took a sample of 1,000, what are the chances that I would even get one or two of that particular rare disease if it's really very rare? And so that would be hard to do. So in a case control, I collect up a whole bunch of cases. It could be something that's really rare. And so that's an advantage for a case control study. But remember, we don't have denominator data. So we can't calculate prevalence, we can't look at risk and that kind of thing. So we are stuck with an odds ratio to do that kind of level calculation. So create some kind of table that's like this for yourself, because if you think about what's the defining feature of a particular study design, and then you can figure out based on that how that is an advantage and how that same thing is a limitation. It's kind of like the double-edged sword. All of our strengths can also be weaknesses. So this is one really helpful way to think about the kinds of questions that you may have on your quiz coming up or on the CPH exam. So thank you for joining me for this video, and I hope you have a great weekend.